2-1 integers and the number line. In this lesson, we have three objectives: to state the coordinate of a point on a number line, to graph integers on a number line, and finally to add integers by using a number line. Let's take a look at this example. Do you like to play board games? In order to play the one popular board game, you must know how to move playing pieces around the board. To do this, you add the numbers rolled on the dice and you move your playing piece to the corresponding number of spaces forward. You also need to know how to move your playing piece backward when directed to do so. Understanding how to add and subtract integers can help you how to play. It is a popular board game which we all know as Monopoly. So, Nidhi, Lynn, Michael, and Domingo are playing the game described above. The chart below shows a turn for each player. How can you present Nidhi's move using numerals? Okay, let's take a look. Nidhi rolls 2, lands on chance, go back 3 spaces. Lynn rolls double, 3 rolls 7. Michael rolls 6, go directly to jail, back 20. And Domingo rolls 9, lands on the community chest, advance to next utility, and forward 11. Okay? You can solve problems such as this one. Okay? So you can solve problems like the one above by using what we call a number line. A number line is drawn by choosing a starting position, usually 0. Okay, and marking off equal distances from that point. The set of whole numbers is often represented on a number line. This set can be written as 0, 1, 2, 3, and so on and so forth, where the 3 dots represent or means the set continues indefinitely. So the set of whole numbers starts with 0, 1, 2, 3, dot, 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 means it continues indefinitely on that part. Okay? Now remember that there's a difference between the set of whole numbers and the set of natural numbers. In the set of natural numbers, okay, you do not include 0. But that's going to be on a later slide. Right now, this is what we have. You have your number line. It starts from 0, which we also call the origin in the coordinate plane, and goes all the way to the right. These are all this is what we call the set of whole numbers. Okay, and although only a portion of the number line is shown, the arrowhead indicates that the line and the set of numbers continue indefinitely. So this arrowhead indicates that number line continues indefinitely. Okay, so we can use the expression 2 minus 3 to represent Nidhi's move. Why? Because Nidhi rolls 2. Okay, that means 2 on the die. Lands on chance and then go back 3 spaces. So she needs to move forward 2 spaces and back 3. So 2 minus 3 to represent Nidhi's move. Okay, and let's take a look at 2 minus 3. 2 minus 3. There it is. Okay, which represents going forward 2 spaces and going back 3 spaces. Okay, when we use a number line to do this, okay, this is how it should look like. The number line below shows that the value of 2 minus 3 should be 1 less than 0. Why is that? Okay, because if you look at this number line, you start with 2 right here, then you go back, you start with 0, go 2 spaces forward, that's when you end up with 2. Then you go back 3 spaces, you end up with this number, which is we call -1. Okay. However, there are no whole number that corresponds to 1 less than 0. So -1 is not a whole number. Write the number 1 less than 0 as -1. This is an example of what we call a negative number. Just a review. So to include negative numbers on number line, we need to extend the number line to the left of 0 and mark off equal distances. The points to the right of 0 are named using a positive sign. The points to the left of 0 are named using the negative sign. 0 is neither positive nor negative. Okay, so you have that number line where everything to the left of 0 is negative, everything to the right of 0 becomes positive, and we read uh, a dash before 5 as -5, and this is read as +5. Okay, which brings us to a new definition. Well, not really, because we learned this last year and in 6th grade as well. Okay, before we go to Venn diagrams here. Okay, not coming up. So the set of numbers used on the number line above is called the set of integers. Let's see if I can bring this up here. There it is. Let's see if I can bring that down. Okay, so the set of integers, and it can be written as the following: -6, -5, -3, -4. Let me just define the set of integers for you. This is not in your book, so I suggest you write this down. Okay, the set of integers. Let's define the set of integers. Okay. Integers. Okay. It is a set of whole numbers and their opposites including 0. Okay, and that is how you define the set of integers. So if you look at our number line right there, the set of integers now will include, again, I need to put 3 dots here: -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, ... Again, let me just remind you that the 3 dots indicate it continues indefinitely. Okay, and we can use a Venn diagram to represent the set of numbers. Okay, so representing the set of numbers. Okay, and if we look at our table right here, we have natural numbers. I mentioned that a few minutes back. Okay, 1, 2, 3, 4, 5. That means it's basically the set of whole numbers, but not including 0. So the set of natural numbers does not include 0. The set of whole numbers includes 0, and the set of integers includes both the natural and whole numbers. Let's take a look at this Venn diagram and see how this works. Look at our Venn diagram. You have your set of natural numbers, 1, 2, 3, 4, 5. Okay, and the set of whole numbers is included in the set of whole numbers. Okay, so you have a set of whole numbers, including the set of natural numbers, and your integers basically include both of them. So your set of integers, okay, will include whole numbers and natural numbers. Okay, so if you notice, natural numbers are a subset of whole numbers, and whole numbers are a subset of integers. Subset meaning it's included in a bigger set. Okay. Last part of this is quite simple. To graph a set of numbers means to draw or plot the points named by those numbers on the number line. The number that corresponds to a point on the number line is called the coordinate of that point, which is given in this example. Name the set of ordered numbers graph. That's if you look at these are the set of numbers that have been graphed. So quite simple. Simply put, the set is -5, -4, -3, -2, -1, 0, 1. and 2. And if you look at letter B, okay, again, you only want to include the sets that have been graphed, sorry, the numbers that have been graphed. So the set is -4, -2, 1, 1, and 3. Okay. Let's take a look at example 2. Okay. At 4:08 a.m., the temperature in Casper, Wyoming was -10 degrees Fahrenheit. By 1:30 p.m., the temperature had risen to 17 degrees to the daytime high. What was the high temperature? Okay, so first, let's draw and label number line. Draw an arrow from 0 to -10. Okay, then draw an arrow to the right, 17 units long. Why -10? Because at 4:08 it was -10 degrees. Oops, there you go. That's our number line right here. So we start with 0 to -10. Okay, and then from -10 we go to 17. Okay, the high temperature of the day was 7 degrees Fahrenheit. Okay, and that's it. On Google Forms, type a summary of what you've learned by responding to the objectives of the lesson and type a question you might want to ask in class about this lesson. Thank you.